Everybody, welcome back to another fun and exciting Algebra 2 class. We are going to be in lesson 8.4 today, so if you'll go ahead and turn there, you'll find that on page 403. 403, lesson 8.4. We're going to be doing applications of right triangles. What does that mean? So whenever you hear applications, you're like, oh man, word problems. Yes, word problems, and you should love word problems because word problems are the answer to your question. What do you mean, Mr. Steve? What question? You always ask me, when will I ever use this? And here you go. Here it is. This is when you'll use it, okay? These are the applications to the word problems, and this is where you get to apply what you've been learning to real life situations. And we'll show you some of those today. But hopefully you love word problems and you want to learn how to solve them so that you can learn how to use math in the real life, all right? And since that's the question you always want to know, when are we going to use this? All right, well, here today is your day. All right, lesson 8.4. Look down at the screen. I wrote down some keywords. These are really helpful keywords for you. So when you're looking at a word problem for like a right angle, trigonometrical style word problem, you're going to see some keywords. You're going to see things like perpendicular to. Well, what does that mean? What does perpendicular to mean? Well, here's what it means. It has a line, okay? And the other line is perpendicular to it. What does that mean? It forms a right angle. Perpendicular means it forms the right angle right here. Okay? And then look. Hey, there's my right triangle. Okay? So perpendicular lines form a right angle, which then allows you to form a right triangle. So watch for that when you see perpendicular. That's going to mean, hey, right triangle. Number 2, height or tall. When you see the word height, here's what that means. Okay, so here's the ground. All right. And if something is 5 feet tall, that means that it's 5 feet from the ground. And so you could write 5 feet right here. Well, look, at the top of that to the ground, you end up with a right triangle again. So this would be the height of something or how tall something is. So be watching for those keywords. Another one is the length or the distance from something. So like if you are here and you walk to here, and let's say this is you. I'm a really good artist, by the way, if you didn't know that. Okay. Oh man, that's a messed up looking face right there. There we go. Okay, one eye is definitely messed up. I'm not sure what happened there, but the other one looks pretty good. So there you are. And you're walking along this line. Well, you could have a right triangle. Like let's say you can see with your eyes, you can see maybe there's a puppy dog here. I mean, look at how good of an artist I am. Okay, that's amazing, right? You guys are like, oh my goodness, Mr. Steve, you're a great artist. I know, it's one of my talents. So let's say I'm seeing the puppy dog, and from my eyesight, and let's say I walk the length or the distance from me to the puppy dog. Well, look what I have. I have a right triangle all of a sudden because that's makes a right triangle. And so these are things that actually are real. I'll go ahead and take that artwork off the board so you don't want to look at that too much longer. Okay. That's length or distance. Another one would be degree or angle. So let's say that you're standing here, here's the ground, and let's say that you're looking at an angle. Okay, you're looking up at an incline. Well, at any point that you want on that, you could make it a right triangle. So wherever you want to draw your line down, you can make this a right triangle with the floor. Okay? And so these are different ways to kind of see that you're going to be dealing with a right triangle question. All right, let's keep going. That chart, that table is on page 403, and you can look at it there. Turn to page 404. Actually, we're going to skip that one. I'm not going to do that one. Let's go to page 405. Page 405. Here's what you're going to see. You're going to see the steps to solving trig word problems, okay? Number 1, we want to draw a diagram of the problem. And again, I'm a great artist, and I know some of you are great artists just like me. So our diagrams might look pretty ugly. But then others of you really actually are good artists, and so your diagrams might look beautiful. It doesn't matter what your diagram looks like. I'm not grading your diagram, okay? I'm grading your math. So you draw it beautiful, fine. Draw it ugly, fine. Doesn't matter, okay? But draw a diagram. So important. That first step is so important. Number 2, select the formula that will apply to the problem. What does that mean? So you're going to choose, am I going to use sine, cosine, tangent? Am I going to use Pythagorean theorem? What am I going to use here? What's the formula that fits this problem? Okay. Number 3, write and solve your equation. Once you figure out what formula you should use, go ahead and write your equation out. And number 4, check your answer. Notice I wrote, make sure you answered the original question in the problem. So the problem is going to give you a question. Maybe you think that you're doing it right, and then you get to the end and you're like, I don't think I actually answered the question. Well, then you can go back and figure out what you need to do. Maybe it's a multi-step problem, and okay, you did the first part. Maybe it was a Pythagorean theorem question where you needed to find a side, and then you could find your angle or whatever that you're looking for. So, whatever the question asks, make sure that you answered it. So don't just stop like halfway through the question and say, oh, I found an answer. It might not be the exact answer that the question is looking for. All right. Let's do one. No, let's just talk about it and let's just kind of work through this. A land survey crew, and I'm on page 405, example 8.4. A land survey crew needs to measure the distance between 2 points, A and C. They are across a river from each other. So here's our A and C, and they are across the river. This is the river. Isn't that a beautiful river? I mean, we could actually, do some more waves. I guess waves would go like this in the river. I don't know. Okay, I'm not really a very good artist, but I'll do this. So this is our river. It's a beautiful river. Beautiful blue water. And so there's our river, okay? Now, across, stop laughing at my river. I don't appreciate that. All right, now across the river, so let's say the land survey crew is here at point A. Actually, they're going to be at point C. So let's say they're at point C. But let's say that maybe one person is over here and he knows where point A is or whatever. So they're over here at point C. Well, you can't really take the tape measure and you can't measure straight across the water, okay? That's going to be a little bit difficult. So what do they need to do? Well, what they can do is what the problem tells us. What does the problem say? The crew measures 100 meters from point C. So in other words, the crew goes down here 100 meters from point C. Let's say that that's 100 meters. We'll write that 100 meters. And they form point B. Okay, so 100 meters from point C, they form point B. Now, if now the crew is standing here at B, they're looking back over to point A, and what do they determine? Here's what they determine. They determine that this angle right here, this is what the problem tells us, is 28 degrees. They say, okay, this is 28 degrees. Well, let's finish off our right triangle here. Okay, so there's our right triangle. 28 degrees, 100. Okay, so this is going to be our reference angle. Let me change the color here so you can see a little bit better. B is going to be our reference angle. So what are we looking for? Well, we're trying to find, this is the opposite. Okay, what do we have right here? We have the adjacent. All right, and then we have the angle. So we have the theta. So now this, we go back up to the steps. All right, so we drew our diagram. Now we need to select the formula that applies to this problem. All right, so how do we select? This is where a lot of students struggle on these. Most of the students can get the picture drawn, and that's not a big deal, okay? But now when they try to figure out what one do I need to use, there's a struggle, and I don't really know why. I'm just going to be honest, okay? So right now we have Sohcahtoa, right? So, that's sine. Ka, that's cosine. And toa, that's tangent. Okay? How do we write sine? Well, let me get rid of this. There we go. Okay, how do we write sine? Opposite over hypotenuse. How do we write cosine? Adjacent over hypotenuse. And how do we write tangent? Opposite over adjacent. Now, let's look back at what we have. Do we have the hypotenuse? No, it's not. There's nothing up here. We don't have the hypotenuse. We don't know the hypotenuse. Do we need to know the hypotenuse? No. Okay. Do we have the adjacent? Yes, we do. It's 100 meters. So we have the adjacent equals 100 meters. Okay. What are we looking for? What's our question mark? Well, it's right here. It's the opposite. So our opposite is our question mark. So let's look at these ones. Which one are we going to use? All right, so let's look one by one. Are we going to use sine? No, why not? Because we don't have the hypotenuse and we're not looking for the hypotenuse, so we don't need sine. Do we need to do cosine? No, because again, we don't have the hypotenuse and we're not looking for the hypotenuse. Look here. That's what we need right there. We need the tangent. Why? Because we have the adjacent and we're looking for the opposite. This is the one that we need. Okay? So here's what we need to do. Now we need to go on to our next one, step 3. Write and solve the equation. So what's our equation for tangent? Tangent of theta equals opposite over adjacent. Now let's plug into that. What's our theta? Well, our theta is 28 degrees. So tangent of 28 degrees equals opposite over adjacent. Opposite is our x. Adjacent is our 100 meters. All right, now let me get rid of this. How are we going to solve this? Well, we're going to solve it like we would any equation. How do I solve an equation? How do I get x by itself? Well, if I'm dividing by 100, I need to multiply by 100. What's that going to do? It's going to cancel that, and it's going to get x by itself. So if I take tangent of 28 times 100, that will give me x. Tangent of 28 times 100. So we would come down here to our calculators, and I would do tangent of 28. So 28 degrees, trigonometrical function, tangent equals 5.314 times 100 times 100 equals 53.709 or 53.71. 53.171 would be our correct answer right there. It does say in this question in your book, round to the nearest foot. Round to the nearest foot. So it doesn't even want us to do the 3 decimal places. It just wants us to do 1 decimal place. So this is the one that we'd look at. We'd look over here. It's less than 5, so it would just be 53 feet would be the answer. Okay. Now it says the last point, and this is the one that we miss sometimes, check your answer. Make sure we answered the question. All right, so we got that this was 53. Okay, that opposite. So what do we want to know? It says a land survey, measured the distance, C determined the answer point A. So all we want to do is we want to measure the distance between. We measured the distance and we got it. Okay, now how can we check that? This is an interesting check. All that you would do is plug it back in. So let's do tangent of 53. If we do tangent of 53, that should give us the same as we got here by dividing that. So tangent of 53. Clear this out. 53 tangent is 1.327. Okay, 1.327. So again, I'm checking it, 1.327. Now let's check our tangent and see. Okay, so how do we check this? We need to take the tangent of 28. So the tangent of 28, and we need to figure out what that equals. So let's go back over here. We're going to go, on my calculator, do 28, and then I do tangent. Tangent of 28 is 0.5317, so 0.53 equals 0.532, I guess. And now we need to say, well, let's figure out the tangent using the 53 and the 100. Okay, opposite over adjacent. So opposite is 53, adjacent is 100. So let's go ahead and divide that out. 53 divided by 100 equals 0.53 equals 0.53. Look, they match. 0.532 and 0.53. That's close enough. That matches. That's the way that you check those, is you would check one by the fraction and one by the angle, since we have all three of those. Okay? Lots of stuff going on there. Let's do one more real quick here. A crew is installing a zip line at an adventure park. The tower is 27 feet tall. Here's the tower right here. That's 27 feet. Feet tall. Remember that? The word tall there? Okay. Or high. And the distance from the tower to the landing spot. And maybe I should have wrote the top of the tower. Okay. So the top of the tower to the landing spot. This, in other words, this wire right here, the zip itself, is 397 feet. All right. What is the angle of the zip line? So in other words, let's kind of finish our right triangle here. All right. So in other words, it wants to know this triangle right over here, or this angle. What is the degree of this angle? What is the incline of the zip line? Okay. And so this is going to be our theta right here. So what do we have? Okay, here's what we have. This is the right angle right here. So we have the hypotenuse. This is the reference angle, so we have the opposite. This one here is the opposite. And what are we looking for? Well, we're looking for the theta. We're looking for the reference angle. So how would we solve this? Which one do we need? Theta equals opposite over hypotenuse. Which one is opposite over hypotenuse? Okay, so this would be the sine. We're using sine. Opposite over hypotenuse is sine. Okay, and so let's just plug it in. Hypotenuse is 397, and the opposite is 27. All right, so how would I figure this out? I have 27 over 397. That's my opposite, 27, over my hypotenuse, 397. I'm looking for the angle. Do you remember how to find the angle? Remember that we're going to use sine -1. We're going to use the inverse function here. So we do sine -1 of that is going to equal our theta. So all we do is go to the calculator. And on mine, I have to put that in parentheses. So I had to put 27 divided by 397 in parentheses. And then I would go up here to my trigonometry. I'd go to my second function, and I'd use my second function of sine. And it says that it is a 3.899 or 3.9 degree angle. 3.9 degrees. Okay. And that example is in your book on page number 406, if you want to look at that example in your book. So there you go. And it says that it wants it to the nearest tenth. That's why I just did just did 1 decimal point, because it wants it to the 10th. Okay. How would you check it? Just do the sine of this and then divide this, and it should come out the same. Okay, I won't do it for time, but it will come out the same because it's the correct answer. So, all right, well, that's all I have for you. I hope you learned something there on application. How do we apply sine, cosine, and tangent to real life situations? There were two real life situations there. One, they were measuring land, maybe to make a map or maybe to sell the property to somebody. The second one, they were building a zip line. And these are real things that people deal with, and they need to know, and they need to use trigonometry to find the answers so that they can build what they need to build or measure what they need to measure. Okay? All right, we'll see you later. Have a good one. Bye-bye.